Welcome to this explainer. Look, if you're a cloud architect, an SRE, or a platform engineer trying to keep enterprise systems highly available without totally bottlenecking your CI/CD pipelines, you are in the exact right place. Today, we're decoding the absolute foundation of site reliability engineering, or SRE, and breaking down the very framework used by the highest performing engineering organizations on the planet. But before we even touch the metrics, let's address the core tension in software engineering, right? How do we actually balance speed and stability? You've got developers who are heavily incentivized to push code, launch features, and maximize release velocity. But then, on the flip side, operations teams are incentivized to maintain uptime and basically prevent system degradation at all costs. So, how do we build an architecture, and honestly, a culture, that satisfies both of these seemingly opposing needs? Well, here is our roadmap for today to figure that out. First, we'll look at the subjectivity problem. Then, SLIs, measuring the reality. Next up, SLOs, setting reliability targets. After that, error budgets, funding innovation. Then we'll cover data-driven engineering decisions, and finally, wrap up with the foundation of SRE. Let's dive right in. All right, kicking things off with part 1, the subjectivity problem. You know how it goes. Without clear, hard measurements, reliability discussions become completely subjective. Before we had structured SRE practices and deeply integrated observability, conversations about service health were pretty much based on feelings, or worse, customer complaints on Twitter. You'd have an engineer saying, "Hey, the database feels sluggish today," or "We seem to be dropping connections." But sluggish isn't exactly an actionable metric for a DevOps team, is it? This subjectivity just creates massive friction between product and engineering. And that brings us to the reliability model. This beautifully illustrates the journey from those subjective debates to actual data-driven engineering. It shows a systematic move, starting from measuring service health with SLIs to defining strict targets with SLOs, calculating your acceptable risk via error budgets, and then finally using all that data to dictate release management decisions. It's about transforming vague feelings into a precise mathematical framework for operating systems at serious scale. Moving right along to step 2, SLIs, or measuring the reality. So, what actually is a service level indicator? Simply put, it's a measurement of some aspect of service performance that directly reflects the user experience. Think of SLIs as your observability instrumentation layer. We're not guessing here. This is the raw, objective telemetry measuring exactly what your users are experiencing in production right at this very moment. Common SLIs include availability, latency, error rate, and request success rate. But listen, in a mature SRE practice, the details absolutely matter. We aren't just looking at some average latency. We're configuring our monitoring to look at P95 or P99 latency, so we actually capture that tail-end user experience. We're measuring the exact ratio of HTTP 500 errors to successful requests over a rolling window. It's all about granular, actionable telemetry that really maps to whether a customer can successfully use your platform or not. Okay, let's look at the next piece of the puzzle. Section 3, SLOs, setting reliability targets. Now, a service level objective defines the target value for an SLI. It's what establishes crystal clear reliability expectations. If the SLI is your raw metric, the SLO is your internal contract. It's that definitive line in the sand, agreed upon by both product and engineering, that basically says here is exactly where the user experience degrades to the point of unacceptable business impact. Let's see how mapping these raw metrics to targets creates a clear engineering foundation. So, for an availability SLI, your corresponding SLO target might be 99.9% monthly uptime. For a latency SLO, the objective might dictate that 95% of all requests absolutely must complete in under 200 milliseconds. And for an error rate SLI, the SLO dictates strictly less than 0.1% failures. Setting these thresholds transforms your raw telemetry into uncompromising operational goals. Which leads us to my absolute favorite part, Section 4, error budgets, funding innovation. An error budget is exactly what it sounds like. It's the amount of downtime or failure actively allowed within an SLO to balance innovation and reliability. And listen, this is a massive paradigm shift for enterprise architecture. We are completely reframing reliability here. We're no longer demanding 100% perfection because, let's face it, that's both physically impossible and crazy expensive. Instead, failure actually becomes a spendable currency. It gives your teams the psychological safety and the mathematical breathing room they desperately need to deploy new features and run experiments. Check out this number, 43.8. That is the exact amount of downtime, in minutes, permitted per month under a standard 99.9% availability SLO. That right there is your budget. If you burn 10 minutes of it on a botched database migration, well, you have exactly 33.8 minutes left. It makes the highly abstract concept of operational risk incredibly tangible for the whole organization. You can actually spend this budget on planned maintenance, chaos engineering experiments, or just use it as a buffer for a really aggressive release schedule. So, how do we use this in the real world? Section 5. Data-driven engineering decisions. Let's compare the two environments. Without air budgets, teams inevitably over-optimize for reliability. Your architecture becomes overly rigid, and release velocity just plummets because everyone is terrified of causing an outage. But with air budgets, reliability suddenly becomes measurable, and trade-offs become fully transparent. It acts as this common, objective language that immediately stops those endless arguments between product managers who desperately want new features shipped yesterday and sysadmins who just want system stability. This gives us a brilliantly simple, objective workflow directly tied to your CI/CD pipelines. Step 1, check the remaining error budget. Step 2, if the budget exists, your pipeline stays open and you continue releases. Step 3, if the budget is exhausted, you halt. Literally, you pause new feature deployments and pivot all engineering efforts toward reliability, paying down tech debt, and system hardening until that budget window resets. It's a strictly enforced, math-based rule. And honestly, this isn't just academic theory. Leading organizations like Google rely heavily on SLOs and error budgets to govern their release management and prioritize engineering work. It completely removes human emotion from the deployment pipeline, turning reliability into a strategic business decision strictly governed by hard data. Let's bring it all together. Section 6, the foundation of SRE. These three elements right here form the unbreakable triad of modern site reliability engineering. You've got SLIs, meticulously measuring the reality of your cloud architecture. You've got SLOs, defining your uncompromising business expectations. And you've got error budgets, systematically balancing that relentless push for innovation with the absolute need for operational stability. It really all comes back to that golden rule of engineering. You can't improve what you don't measure. You simply cannot achieve high velocity and high availability by just guessing. Objective, properly instrumented data is literally the only viable path forward for any serious tech organization today. So I'll leave you with this final thought. Are your engineering decisions based on objective data or just subjective feelings? Tomorrow morning, take a hard look at your observability stack. Are you actively tracking SLIs and enforcing strict SLOs, or are you kind of just hoping for the best every time you merge to main? Thanks for joining me on this explainer. Keep measuring, keep building resilient systems, and I'll catch you next time.